Welcome to Lab 4 on the Lensometer. For this lab, we'll ask you to complete Part 1 on your own based on this video and the data that we give you before you come to the lab. To start, we've placed a +7 diopter lens 25 centimeters downstream from the light source as instructed. We locate the image formed by this lens and measure the image distance. You'll notice the image is inverted and slightly magnified. In this case, the image distance is 33 centimeters. So you can use the Vergence equation to verify that in your notebook. Next, we add a -5 diopter lens 20 centimeters downstream from the positive lens. Locate the new image formed by this lens system and measure the distance from the negative lens. We find that's 39 centimeters. Again, using the Vergence equation, we can compute the predicted location for the image formed by this two-lens system. This is excellent practice, and we'll go through it a little bit more detail now. The first step is to consider the original object and the effect of the +7 diopter lens. Using the Vergence equation, v equals u plus p, and the object distance, we can calculate the image distance, little v. Again, for this experiment, little u has been measured to be 25 centimeters. And keep in mind the sign convention tells us that because that object is upstream from the lens, that should be a negative number. So negative 25 centimeters will be the value for little u. P, of course, is the power, +7 diopters in this case. So you can evaluate this expression and compare to the measured value of little v equals 33 centimeters. Now we can add the second lens, in this case the -5 diopter lens, 20 centimeters downstream from the +7 diopter lens. And we'll have to take that distance into account when calculating little u, because we found it relative to the +7 diopter lens. And that distance we found was 33 centimeters. So from that combination of numbers, you can find little u and then evaluate the Vergence equation. In this case, using the power -5 diopters for the lens. Go through that process and compare that result to the measured value of little v in the experiment, which I found to be 39 centimeters. In part 2, we'll be exploring the lensometer, which is another two-lens system. That's the reason we had you go through that Vergence equation, to get familiar with how two-lens systems work, and especially how to use the Vergence equation in that situation. In the lensometer, we place an object, that'll be the light source, and then a standard lens at its focal length to create parallel rays down the bench. Then we'll take those parallel rays and focus them onto a screen to form a clear image. So the layout of the ray diagram looks like this. I'm going to switch to an animation now that lets us illustrate how the rays change when you put in a third lens that we'll call the test lens. Here we see an animated version of the same rays with the object on the left, parallel rays, and then the image on the right. I'm going to move another positive lens, one focal length downstream from the initial standard lens. Now you see the image is no longer formed at the screen because the rays come to a focus too soon. To correct for this, we move the object closer to the standard lens in order to form parallel rays right before the last lens. You'll see the rays are diverging from the object as well as after the standard lens, but then parallel after the test lens. This is just right in order to form a clear focus on the image plane at the end of the bench. To set this up, we'll autocollimate a +5 diopter lens. That will give us the parallel light we need traveling down the bench. We call this lens the standard lens. When you're setting this up, make sure to leave yourself some room on each end of the light source. Start at about 10 centimeters from one end. That gives you room to move that light source forward or backward as you'll need to during the lab. Here's a look at the full setup. You see the +5 diopter standard lens, +7 diopter lens, and then the image screen. We'll add a test lens, one focal length downstream from the +5D lens, right about where I'm indicating. And then you'll adjust the light source position in order to form a new clear image while the test lens is in place. There are formulas in the lab that allow you to calculate the power of the test lens from the distance x that you've moved the object.